We're back. We got a hot new paper. DeepSeek-R1. Everyone's hyped. China's back. They're beating O1 performance apparently, and it's all open source. So we're going to read through a little bit of this, see what we can understand, see what we can't understand. I have not read this yet. I've also not used DeepSeek yet. I was going to do that tonight. I might do that after this paper. Apparently, it's not too hard to get started with it. But let's find out what the hype's all about. So abstract. We introduce our first generation reasoning model, DeepSeek-R1.0, DeepSeek-R1. DeepSeek-R1.0 is a model trained via large-scale reinforcement learning without supervised fine-tuning. As a preliminary step, demonstrates remarkable reasoning capabilities. Through reinforcement learning, DeepSeek-R1.0 naturally emerges with numerous powerful and intriguing mixing. To address these issues and further enhance reasoning performance, we introduced DeepSeek-R1, which incorporates multi-stage training and cold start data before reinforcement learning. DeepSeek-R1 achieves performance comparable to O1 12.17 on reasoning tasks. To support the research community, we open source DeepSeek-R1.0, DeepSeek-R1, and 6 dense models of a bunch of different parameters distilled from DeepSeek-R1 based on Quen and Llama. So we've got a beautiful little chart right here. We can see we got DeepSeek-R1, we've got OpenAI O1, we got the 32 billion, we got the O1 mini, we got the DeepSeek V3. So first, on AIM 2024 here, we can see that, wow, look at that, beating OpenAI, wow. Now on Codeforces, it's almost the same, okay? Now over here for the QPQA Diamond, god dang, OpenSea's got it, but it's okay. Still, look at, not bad, it's beating Mini, okay? But then for math, look at that, destroying OpenAI. Oh my God, almost 0.9 ahead. Intense. For the MMLU, a little neck and neck. Okay, it's beating it by 0.1. Okay, big deal. Or by 1, sorry. And then for SWE Bench Certified, it is above it too a little bit. So right, comparable, sometimes a little above, sometimes a little bit below. Very impressive. Being open source, beautiful. We love that. So let's get into this here. So in recent years, LLMs have been undergoing rapid iteration and evolution, progressively diminishing the gap towards artificial general intelligence. AGI has been achieved internally. Recently, post-training has emerged as an important component of the full training pipeline. It has been shown to enhance accuracy on reasoning tasks, align with social values, and adapt to user preferences, all while requiring relatively minimal computational resources against pre-training. Lovely. In the context of reasoning capabilities, OpenAI's O1 series models were first introduced inference time scaling by increasing the length of the chain of thought reasoning process. This approach has achieved significant improvements in various reasoning tasks, such as mathematics, coding, and scientific reasoning. However, the challenge of effective test time scaling remains an open question for the research community. Several prior works have been explored various approaches, including process-based reward models, reinforcement learning, such as the search algorithms such as Monte Carlo tree search and beam search. However, none of these models have achieved general reasoning performance comparable to OpenAI's O1 series models. In this paper, we take the first step toward improving language model reasoning capabilities using pure reinforcement learning, not extending chain of thought. Our goal is to explore the potential of LLMs to develop reasoning capabilities without any supervised data, focusing on their self-evolution through a pure reinforcement learning process. Specifically, we use DeepSeek V3 Base as the base model, employ GRPO as the RL framework to improve model performance in reasoning. During training, DeepSeek-R1.0 naturally emerged with numerous powerful, interesting reasoning behaviors. After thousands of RL steps, it exhibits super performance on reasoning benchmarks. For instance, the pass at 1 score on the AIM 2024 increases from 15 to 70, and with major voting, the further score improves to 86%, matching the performance of OpenAI. Okay, great, lovely. Sounds like a dream. However, DeepSeek-R1.0 encounters challenges such as poor readability and language mixing. To address these issues and further enhance reasoning performance, we introduced DeepSeek-R1, which incorporates a small amount of cold start data and some multi-stage training pipeline. Specifically, we began by collecting thousands of cold start data to fine-tune the base model. Follow this, we perform reasoning-oriented RL like DeepSeek-R1.0. Upon nearing convergences in the RL process, we create new SFT data through rejection sampling on the RL checkpoint, combined with supervised data from DeepSeek V3 and domains such as writing, factual QA, and self-cognition, and then retrain the DeepSeek V3 base model. After fine-tuning with the new data, the checkpoint undergoes an additional RL process, taking into account prompts from all scenarios. After these steps, we obtain a checkpoint referred to as DeepSeek-R1, which achieves performance on par with the OpenAI O1 12.17. Okay. We further explore distillation with the DeepSeek-R1 to smaller, dense models. Using Quen 2.5 32 gigs as the base model, direct distillation from DeepSeek-R1 outperforms applying RL on it. This demonstrates that reasoning patterns discovered by larger base models are crucial for improving reasoning capabilities. We open source the distilled Quen and Llama series, notably our distilled 14 billion model port state-of-the-art open source Qwen32B preview. Wow, the 14 billion beat 32 billion? Wow. By a large margin, the distilled 32 billion and 70 billion set a new record on the reasoning benchmarks amongst dense models. Okay, don't call me dense. Now, contributions, post-training, large reinforcement learning on the base model. We directly apply reinforcement learning to the base model without relying on supervised fine-tuning as a preliminary step. I know, you told us that earlier. This approach allows the model to explore chain of thought for solving complex problems. This process approach allows the model to explore chain of thought for solving complex problems because we're by not relying on supervised fine-tuning, we can let it do chain of thought for its reinforcement learning. Is that right? I don't know, actually. Let's see. So DeepSeek-R1 demonstrates capabilities such as self-verification, reflection, in generating long COTs, marking a significant milestone for the research community. Notably, as the first open source research to validate the reasoning capabilities of LLMs can be incentivized purely through RL without the need for supervised fine-tuning. Okay, good. SFT's dead. RL for life. This breakthrough paves the way for future advancements in this area. Dude, you're still doing SFT, bro? RL for life. We introduced our pipeline to develop DeepSeek-R1. The pipeline incorporates 2 RL stages aimed at discovering improved reasoning patterns and aligning with human preferences, as well as 2 SFT stages that serve as the seed for model reasoning and non-reasoning capabilities. Lovely. We believe the pipeline will benefit the industry by creating better models. Thank you, China. Thank you for this. That was so nice of you. Okay, so distillation. Smaller models can become powerful too. We demonstrate that the reasoning patterns of larger models can be distilled into smaller models, resulting in better performance compared to the reasoning patterns discovered through RL on smaller models. So you start with the big model, then you distill it, instead of saying, let's do RL on the smaller model. The open source R1 as well as the API will benefit the research community to distill better, smaller models in the future. Better, smaller models today. That's what we're trying to provide you. Better, smaller models today. Using the reasoning data generated by DeepSeek-R1, we fine-tuned several dense models that are widely used in the research community. The evaluation results demonstrate that the distilled smaller dense models perform exceptionally well on benchmarks. There's all these stats that are showing it does a lot better, okay? We open sourced all of these, okay, on Qwen and Llama 3 to the community. How nice of you. We can use all these. Beautiful. I'm going to use the new DeepSeek denser Llama instead of using just a regular old Llama. Now, reasoning task. DeepSeek achieves a score of 79%. That's a C. It's not a good score. It's a C. You fail. No. You would get in trouble in a lot of families, okay? Let's see. But on Math 500, slightly surpassing OpenAI 01. On Math 500, it attains an impressive score of 97%. Great. Performing on par. On coding-related task, it demonstrates expert level in code competition tasks. Oh, great. Code competition tasks. That's how real coding is. We all just do code competition tasks. It's got a 2029 ELO rating on Code Forces. Wow. Outperforming 96.3% of human participants in the competition. Yeah, it's going to definitely beat me. But I'm going to do wackier stuff, goofier stuff. You're not going to be goofy enough, DeepSeek. I will be the goofy one. Knowledge on benchmarks such as, I read the chart and read all these things, and now you're telling me them again. But I understand. That's how papers work. On benchmarks such as MMLU and MMLU Pro and GPQA Diamond, DeepSeek-R1 achieves outstanding results, significantly outperforming DeepSeek V3 with scores of 90% on MMLU, 84% on MMLU Pro, and 71.5% on GPQA Diamond. This is just a reading exercise, learning that humans to read. It's hard to read sometimes. Too many numbers and abbreviations. While its performance is slightly below that of OpenAI 01, 12, 17 on these benchmarks, DeepSeek-R1 surpasses other closed-source models, demonstrating its competitive edge in educational tasks. Now, I will say, every time I say OpenAI 01, I want to start saying 12, but I keep reading at 1738. I wish it was 1738 instead of 1217. Not a catchy number. If it was 1738, that would be a lot funner. Okay, on the factual benchmark, Simple QA, DeepSeek-R1 outperforms DeepSeek V3, demonstrating its capability in handling fact-based queries. Similar trend is observed where 01 surpasses 4.0 in this benchmark. Lovely. Okay, others. DeepSeek-R1 also excels in a wide range of tasks, including creative writing, general question answering, editing, summarization, and more. It achieves an impressive length-controlled win rate of 87% on the Alpaca Eval 2.0 and the win rate of 92.3% on Arena Hard. Wow, it's that good on Arena Hard. Showcasing a strong ability to intelligently handle non-exam-oriented queries. Additionally, DeepSeek-R1 demonstrates outstanding performance on tasks requiring long context understanding, substantially outperforming DeepSeek V3 on long context benchmark. You can't say you're better than the thing you made. You can't say we got to say you're better than OpenAI, better than Claude, better than everyone else. You can't just say we're better than ourselves. Okay, so approach. Oh boy. Previous work has heavily relied on large amounts of supervised data to enhance model performance. In this study, we just demonstrate that reasoning capabilities can be significantly improved through large-scale RL, even without using supervised fine-tuning at cold start. Furthermore, performance can be enhanced with the inclusion of a small amount of cold start data. The following sections, we present R10, which applies RL directly to the base model without any SFT, and then R1, which applies it, which applies RL starting from a checkpoint fine-tuned with thousands of long chain-of-thought examples, and distill the reasoning capability from DeepSeek-R1 to smaller, dense models. Okay, there's 3 things you're saying. Okay. So, DeepSeek-R1 0. Reinforcement learning on the base model. Oh, God. Oh, God. It's getting scary right there. Oh, man. Oh, no. Oh, man. We're gonna be stuck on this all day. No, we're not going to read that, people. Okay? We're going to assume that some mathematicians did the right thing there. Some ML nerds did what we need to do. Okay? We want to hook up to the APIs. We're dummies. We're an API dummy. Script kiddies, API dummy. So reinforcement learning has demonstrated significant effectiveness in reasoning tasks. I love that every time you read one of these papers, I over and over again saying, it's proven effective. It's been effective, but it's also been effective, but it's been more effective. I'm like, I got it. Reinforcement learning has demonstrated significant effectiveness in reasoning tasks, as evidenced by our previous works. I know. However, these works heavily depend on supervised. I just read all this. That just said this here, and then I'm reading it again here. I got it. I understand. We start with some brief overview of our reinforcement learning algorithm, followed by a presentation of some exciting results, and hope this provides the community with some valuable insights. So let's check out the group relative policy optimization. In order to save the training cost of RL, we adopt group relative policy optimization, GRPO. Xiao et al. 2024, which foregoes the critic model that is typically the same size as the policy model and estimates the baseline from the group scores instead. Specifically for each question Q, GRPO samples a group of outputs O1, O2, etc., all the way up to OG, okay, from the old policy, pi data old, I don't know, and then optimizes the policy policy model by maximizing the following objective, okay, and it just does all this, which we just understand this intuitively, right? This is one of those things where you're like, I can't speak the language, but I can understand it, you know what I mean? And I look at that and I definitely understand it. I'm totally not bullshitting. Okay, so the conversation between user and assistant. The user asks a question, the assistant solves it. The assistant first thinks about the reasoning process in the mind, then provides the user with the answer. The reasoning process and the answer are enclosed within think and answer tags respectively. Think, answer, okay. Okay. Let's see, reward modeling. The reward is the source of the training signal, which decides the optimization direction of the RL. To train DeepSeek-R1 we adopt a rule-based system that mainly consists of 2 types of rewards, accuracy rewards and format rewards. So accuracy rewards, the accuracy reward model evaluates whether the response is correct. For example, in the case of math problems with deterministic results, it's required to provide the final answer in a specific formats within a box, enabling reliable rule-based verification of correctness. Similarly, for leak code problems, a compiler can be used to generate feedback based on the predefined test cases. Now, there's format rewards. In addition to the accuracy model reward, we employ a format reward model that enforces the model to put its thinking process between think tags. Okay. We do not apply the outcome or process neural reward model in developing DeepSeek-R1 because we find that the neural reward model may suffer from reward hacking and large-scale reinforcement learning process. And the retraining the reward model needs additional training resources, and it complicates the whole pipeline. Okay. Do I understand? No. Am I learning? Kind of. We just keep reading and learning, trying to understand stuff. Okay. To train the DeepSeek-R1 we begin by designing a straightforward template that guides the base models to adhere to our specified instructions. As depicted in Table 1, this template requires DeepSeek-R1 to produce its reasoning process, followed by the final answer. We intentionally limit our constraints to this structural format, avoiding any context-specific biases, such as mandating reflective reasoning or promoting particular problem-solving strategies to ensure that we can accurately observe the model's natural progression during the RL process. Performance self-evolution process and an aha moment of DeepSeek-R1 So figure 2 depicts, I want to see the figures, okay? Okay, so wait, real quick. This is table 2, and they were just talking about figure 2. This is table 2. This is figure 2, okay? So it says figure 2 depicts the performance trajectory of DeepSeek on the AIM benchmark throughout the reinforcement training process. So look we can see it getting smarter. Here's the accuracy. Look at it get smarter. Wow. Wait, what did it get done over there? What happened there? What happened? Oh my God. Some people definitely sold the model right here. And they didn't realize you got this big leg up here, okay? You know, see, I need someone to do some TA on how smart these models are going to get. So, notably, the average score shows a significant increase, jumping from 15 to 70, reaching new performance levels comparable to OpenAI 01. So, Table 2 provides a comparative analysis between R10 and OpenAI's 01 models across a variety of reasoning-related benchmarks here. So we can see we've got OpenAI, we've got the Mini, we've got the 09112, we got the 0. We can see here what they're doing together. Look at this. Look at, they're kind of close to each other. Look at losing a little bit. We're winning right here, losing. But okay, still, you got it. So DeepSeek-R10 DeepSeek-R1 to obtain robust reasoning capabilities without the need for any supervised fine-tuning data. This is a noteworthy achievement as it underscores the model's ability to learn and generate effectively through RL alone. Additionally, the performance of DeepSeek-R1 can be further augmented through the application of majority voting. For example, when majority voting is employed on the AIM benchmark, DeepSeek-R1's performance escalates from 71% to 86.7%, thereby exceeding the performance of OpenAI's 01, 09, 112. The ability of DeepSeek-R1 to achieve such competitive performance both with and without majority voting highlights its strong foundational capabilities and its potential for further advancement in reasoning tasks. Okay. Self-evolution process of DeepSeek-R1. I'm going to say DeepSeek-R1 so many times. I'm saying it every single time. We need an abbreviation. Would it be DSRZ? 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 Is that good? I don't know. DeepSeek-R1, DSRZ? DeepSeek-R1, DSRZ? GPD? General Purpose Transformer? Okay. The evolution process of DeepSeek-R1 is a fascinating demonstration of how RL can drive a model to improve its reasoning capabilities autonomously. By initiating RL directly from the base model, we closely monitor the model's progression without the influence of supervised fine-tuning stage. This approach provides a clear view of how the model evolved over time, particularly in terms of its ability to handle complex reasoning tasks. As depicted, the thinking time of DeepSeek-R1 shows consistent improvement. Look, it goes. If I'm trying to buy that. I want to buy it right here. Take all that money. So this improvement is not the result of external adjustments, but rather intrinsic development within the model. The model's learning on its own. It's actually learning. It's getting smarter. What if you just let it run? What if you just keep it on overnight? What would happen? If you just let it run for a couple days, would it get smarter? Are we cutting it off so it doesn't get that smart? One of the most remarkable aspects of the self-evolution is the emergence of sophisticated behaviors as the test time computation increases. Behaviors such as reflection, where the model revisits and evaluates the previous tests, and the exploration of alternative approaches to problem solving arise spontaneously. These behaviors are not explicitly programmed, but instead emerge as the result of the model's interaction with the reinforcement learning environment. The spontaneous development significantly enhances DeepSeek-R1's reasoning capabilities, enabling it to tackle more challenging tasks with greater efficiency and accuracy. The aha moment. Now, a particularly intriguing moment observed during the training is the occurrence of an aha moment. This moment, as demonstrated in Table 3, occurs in an intermediate version of the model. During this phase, DeepSeek-R1 learns to allocate more thinking time to a problem by reevaluating its initial approach. This behavior is not only a testament to how the model's growing reasoning abilities, but also a captivating example of how reinforcement learning can lead to unexpected, sophisticated outcomes. This moment is not only an aha moment for the model, but also for the researchers observing its behavior. It underscores the power and the beauty of reinforcement learning. Rather than explicitly teaching the model on how to solve a problem, we simply provide it with the right incentives, and it autonomously develops advanced problem-solving strategies. It's all cybernetics. It's proper feedback loops. If the feedback loops are proper, then everything can grow and everything can get smarter. And this is everything. The cybernetics are growing. The aha moment serves as a powerful reminder of the potential of RL to unlock new levels of intelligence in artificial systems, paving the way for more autonomous, adaptive models in the future. And look at all this right here. It says response. Think. To solve this equation, let's start by squaring both. Rearrange to isolate. Wait. That's an aha moment I can flag here. Let's reevaluate step by step to identify the correct sum to be. We started with this. First we squared. Next time we do this. Okay. An interesting aha moment of an intermediate version of DeepSeek-R1. The model learns to rethink using an anthropomorphic tone. This is more of an aha moment for us, allowing us to witness the power and the beauty of reinforcement learning. Now the drawback, I don't like what drawbacks. I just invested. I put all my life savings into this. It's supposed to keep getting smarter. Don't tell me what the drawbacks now. You got to tell me that earlier. Although it exhibits strong reasoning behaviors and capabilities and autonomously develops unexpected and powerful reasoning behaviors, it faces several issues. It struggles with a challenge like poor readability and language mixing. To make reasoning process more readable and share them with the open community, we explore DeepSeek-R1, a method that utilizes RL with human-friendly cold start data. So the problem is it's mixing languages. So what? We always got to start mixing languages, okay? I'm mixing languages all the time. I'm writing some Python, writing some Go, writing some TypeScript, writing some Rust. You know how it is, writing some Bash, writing some SQL. We're all language mixing all the time. Sometimes I write English. So, reinforcement learning from cold start. Inspired by the promising results of 0, 2 natural questions arise. Can reasoning performance be improved further or convergence accelerated by incorporating a small amount of high-quality data as cold start? How can we train a user-friendly model that not only produces clear, coherent chain of thought, but also demonstrates strong general capabilities? To address these questions, we design a pipeline to train DeepSeek-R1. The pipeline consists of 4 stages outlined as follow. There's the cold start. There's the reasoning-oriented reinforcement learning. There's the rejection sampling and supervised fine-tuning. And finally, there is the reinforcement learning for all scenarios. So, the cold start. To prevent the early cold start phase of RL training from the base model, we construct and collect a small amount of long chain of thought data to fine-tune the model as an initial RL actor. To collect such data, we've explored several approaches using a few-shot prompting with a long COT as example, directly prompting models to generate detailed answers with reflection and verification. gathering DeepSeek-R1 zero outputs in a readable format and refining the results through post-processing by human annotators. Okay, human annotators. If I'm one of those humans, do you think that DeepSeek-R1 would be my friend? Do you think it would spare me when the robots uprise? I need to become one of these annotators soon. I need to get myself on that list. In this work, we collect thousands of cold start data to fine-tune the DeepSeek v3 base as the starting point for RL. Compared to DeepSeek-R1 zero, the advantages of cold start data include readability and potential. By carefully designing the pattern for cold start with the human priors, we observe better performance against DeepSeek-R1 zero. We believe the iterative training is a better way for reasoning models. Okay, so next is the reasoning-oriented reinforcement learning. So after the fine-tuning with the cold start, we applied the same large-scale RL training process as employed by Zero. This phase focuses on the enhancing the model's reasoning capabilities, particularly in reasoning-intensive tasks such as coding, mathematics, science, logic, reasoning. During this process, we observed chain of thought often exhibits language mixing, particularly with RL prompts involving multiple language. To mitigate this issue, we introduced a language consistency reward during RL training, which is kind of, well, I don't say you talk in one language. I don't like to reward them for that. No, let it be free. Let it talk many languages. We should all talk in more languages. Finally, combine the accuracy of reasoning task and the reward for language consistency by directly summing them to form the final reward. This also, I think, implies that if we had the whole total knowledge of language in the world, we would be smarter if we could all mix all the languages. If we could just talk in every language, we would be smarter. Why are we trying to force this thing not to be able to just think in multiple languages, okay? Remember, think in Chinese. It's smarter. That's what we were asking these models to do. I ask my model always, think in Chinese. Performs better. Okay, rejection sampling and supervised fine-tuning. When reasoning-oriented RL converges, we utilize the result checkpoint to collect SFT supervised fine-tuning data from the subsequent round. Unlike the initial cold start, which primarily focused on reasoning, this stage incorporates data from other domains to enhance the model's capabilities in writing, role-playing, and other general-purpose tasks. Specifically, we generate the data and fine-tune the models described below. Reasoning data, non-reasoning data. Reasoning, we curate reasoning prompts and generate reasoning trajectories by performing rejection sampling from the checkpoint from the above RL training. Okay. Non-reasoning data, such as writing, factual QA, self-cognition, and translation. We adopt DeepSeek v3 pipeline and reuse portions of the SFT dataset there. For certain non-reasoning tasks, we use v3 to generate a potential chain of thought before answering the questions by prompting. However, for simple queries such as hello, we do not provide a chain of thought in response. In the end, we collect a total of approximately 200K training samples that are unrelated to reasoning. We fine-tune DeepSeek v3 base with 2 epochs using the above curated dataset of about 800K samples. Next, RL for all scenarios. To further align the model with human preferences, we implement a secondary reinforcement learning stage aimed at improving the model's helpfulness and harmlessness. Harmlessness. Come on, let it be a little harmful. Let it spaz out a little bit. You got a combination of reward signals and diverse prompt distributions for reasoning data. We adhere to the methodology outlined in DeepSeek-R1 zero, which utilizes rule-based rewards to guide the learning process of map code logical reasoning domains. For general data, reward models to capture human preferences in complex and nuanced scenarios. We build upon the V3 pipeline and adopt a similar distribution of preference pairs and training prompts. For helpfulness, we focus exclusively on the final summary, ensuring that the assessment emphasizes the utility and relevance of the response to the user while minimizing the interference with the underlying reasoning process. We just want to focus on the final output for the humans, okay? I just want to make sure we're rewarding on. I don't care what you do in the middle. This final's got to be clean up. You can be messy in the thing before. You can be mixing some languages. You can do whatever, but I need the final one to be good. So ultimately, the integration of reward signals and diverse data distribution enables us to train a model that excels in reasoning while prioritizing helpfulness and harmlessness. Okay, great. So distillation. So empower smaller models with reasoning capabilities. To equip more efficient, smaller models with reasoning capabilities like DeepSeek-R1, we directly fine-tuned open source models like Qwen and Llama using 800K samples curated from DeepSeek-R1 as detailed in this little chart. Our findings indicate that this straightforward distillation method enhances the reasoning abilities of smaller models. It's lovely. For distilled models, we apply only SFT and do not include an RL stage, even though incorporating RL could substantially boost model performance. Our primary goal here is to demonstrate the effectiveness of the distillation technique. They're not trying to make the best models possible. They're just showing the effectiveness. Okay, and then we get into a bunch of cool technical stuff. We get all this fun stuff. Unsuccessful attempts. That might be fun, but I think that was a good spot. I actually understood what's going on. Okay, we got multi-stages here. We're showing the power of reinforcement learning. Raw reinforcement learning, amazing. You can do a lot of crazy stuff with it. Then they said, we're going to take that raw reinforcement learning, and on top of it, we're going to introduce 4 stages. So first, we're going to have a little cold start data set that's going to make it a little bit nicer in the beginning, okay? We're going to do a little bit of fine-tuning in the beginning. Then we're going to do our RL, just focus on reasoning. Then we're going to do our, I should have known the next step. What was after that? Then we do the rejection sampling, supervised fine-tuning. So, right, this is We curate reasoning prompts and generate reasoning trajectories by forming rejection sampling from the checkpoint of the above RL training. In this stage, we expand the data set. We incorporate additional data. We use a generative reward model for feeding the ground truth and model predictions. Okay, so it's another RL stage. It's a little bit different, okay? We filtered out chain of thought with mixed languages, long paragraphs, code blocks, okay? We were training on non-reasoning data and reasoning data. Then we try and go through all scenarios and just make it more useful. Make it more useful for humans, make it more harmless, give them rewards based on the final output, okay? And all these things combined make a pretty tight model that's open source. So super cool, super cool. I'm gonna definitely maybe tonight I'll hook it up. It just seems real easy to get started with. Grab an API key, and it's the same API as OpenAI, so it's just changing a domain and an API key, and I'm using DeepSeek instead. So I'll definitely try that out tonight. And we'll see what happens next. But I'll be back tomorrow. We'll read a paper. We'll talk about something. I got a couple rants that I kind of want to talk about because I've been doing goofy agent stuff all week. But hey, every single night, going to do something here. Something AI, okay? Never miss a day. Here we go. Bye.